Today I will be talking about the break-even analysis. I will first start off by introducing a few key terms and aspects of the break-even chart. Then I will go more in depth by comparing the changes in various components and its effect on the chart. And finally, I will use a real-life example to illustrate the calculations required. Firstly, we must understand that the break-even chart is plotted on an XY Cartesian plane. The x is the horizontal axis, while the y is the vertical axis. In a break-even chart, the x-axis represents the quantity of output in specified units, while the y-axis represents the cost of revenue in dollars. The break-even chart portrays four main factors. They are represented by the colored lines, where the blue line represents the total revenue, or total income of a business, the red line representing the total variable cost, otherwise known as expenses that change in proportion to the activity of a business, and the green line representing the total fixed cost, or business expenses that are constant whatever the quantity of goods or services produced at. Finally, the total cost line, represented by the purple line, is known as the sum of total fixed costs and total variable costs. Moving on, the break-even point is known as the point on the graph where the total revenue of the business is just enough to cover its total costs. This is represented by the point of intersection between the total revenue line and the total cost line. There are two components to the break-even point, namely the break-even quantity and the break-even revenue. The break-even revenue represents the amount of revenue needed to cover its costs, which is $150,000 in this case. On the other hand, the break-even quantity is the x value of the coordinate, which is 25,000 in this case, representing the quantity of output required to break even. However, what if the revenue exceeds the cost? In this case, we have a profit, which is represented by the gray shaded area below. On the contrary, when the cost exceeds the revenue made, we have a loss, represented by the yellow shaded area. Finally, businesses would like to know how far away they are from breaking even when making a profit. Thus, a margin of safety is introduced. The margin of safety is referred to how much quantity of output a company can lose until it hits the break-even mark. For instance, if a company makes a profit of the red shaded area, the margin of safety will therefore be the difference or gap between the break-even quantity and the respective quantity at 34,000 units. Next, let's explore how changes in different components will affect the chart. Here, we have a break-even chart with the price of output at $62 per unit, total fixed cost as $400,000, and average variable cost at $40. When we shift the price from $62 per unit to $76, we can observe a significant change in all components of the graph except for the fixed cost. It is important to note that all components increase except for the break-even point and the fixed cost. The break-even point drops in correspondence. Vice versa also applies, meaning that if price increases, everything else would decrease and break-even point would rise. Next, this chart shows changes due to the change in average variable cost. Comparing to the first graph, we can see that generally everything decreases as the total costs are now higher, which further causes a point of intersection to rise. Thus, as average variable cost increases, everything else decreases except for break-even point as it rises. Fixed cost remains the same, and vice versa once again applies. Change in the total fixed cost is also similar. However, as we are increasing fixed cost this time, everything else decreases due to the higher cost, and the break-even point once again decreases. Now let's move on to look at the real-life example. Toyota is an automobile manufacturing company. The CEO would like to target a profit of 380 million yen. To obtain this, we must understand these few aspects. Let's see if we can solve it. Given that the total fixed cost is 800 million and price per hybrid is 30,000 yen and average variable cost to be 15,000, we can use these information to obtain the break-even quantity, which is given the equation break-even quantity equals total fixed cost over price minus average variable cost. The result is 54,000. This is represented in units, as the company requires 54,000 units to break even. Then we obtain the break-even revenue through the equation break-even revenue equals break-even quantity multiplied by price, which in this case results in 1,620 billion yen. Through obtaining these values, we get a break-even point to be these coordinates. However, the CEO wants to know the required revenue and the quantity for the target profit of 380 million yen. Thus, on top of the break-even point, we add the profit onto the break-even revenue to obtain 2 billion yen. This is the amount of revenue required to get a target profit of 380 million. By plugging the revenue into the equation price times quantity, we will then obtain a quantity of 66,700 cars required. Finally, through this, the margin of safety is the target quantity subtract the break-even quantity, which obtains a value of 12,700 cars. This is the break-even chart for this example. Thank you for listening.